Thank you, Liam, for the introduction. Once again, welcome all to APAC Virtual Summit Day 2. We will be covering verticals as already mentioned. For those who do not know me, my name is Seiko. I'm an applications engineer at Formlabs. I'm located in Singapore, and I'll be covering the manufacturing and engineering vertical. So in this session, I'll quickly cover a broad intro to 3D printing within manufacturing and engineering, the target applications together with some case studies for each application, the competitive landscape, Formlabs strengths, and our strategy going forward, and finally with some Q&A. Once again, don't forget, questions go into Q&A. So with that, let's begin. This session's vertical is in manufacturing and engineering, looking at the overall sales and revenue of 3D printing of desktop and industrial 3D printers. So this is not necessarily just Formlabs, but looking at 3D printers as a whole. 3D printers have skyrocketed in revenue, increasing by a factor of 8 over the past almost 9 years, and with 100 times in 3D printer sales. With these printers, these applications are soaring as well. Printers have this impression that they're meant for one-off parts and prototyping, hobby parts, which is most definitely true. I think you guys are fully aware of this, but this has been gradually and is also gradually changing to applications with not just one-off prints, but more in small-scale production or more customized parts like dental aligners and customized jewelry and earbuds and so on. So we do see the trend where 3D printed parts being used as more functional parts in a larger scale of production. So this part of the session, I'll focus more on the manufacturing and engineering vertical, which is actually our largest vertical than any other single vertical here at Formlabs. We have been working with and also partnering up with many leading companies in the field. I couldn't possibly cover each of their applications, but I'll cover some target applications within this vertical to sort of uncover a sense of scale to some of these applications and some pain points you might see when you are talking to a potential customer of this field. So starting off the target applications include, or what I will cover today will be prototyping, tools and tooling aids such as jigs, molds, brackets, and then finally talk about production. So moving on, prototyping. Prototyping is a very common application that I believe you guys are dreading to hear about because you guys are very familiar with, but I do want to stress prototyping is a very easy way to enter a entryway and a good way to sort of start with upselling. So our resin portfolio and versatility of our printers really do shine, especially in prototyping, allowing for ergonomic features with a combination of our flexible resins as well. And we also do have our draft resin, especially with a lot of your feedback to say that competing with FDM, the biggest pain point is in the speed. Draft resin was specifically designed not only for fast printing, but also for minimal cure. So I do understand some of our printers or resins actually, they have 60 minutes of curing on top of their print times. We have literally addressed both the print time and the curing time as well. And it's sort of smooth-ish looking compared to FDM and also isotropic, meaning unlike FDM parts, they're more practical parts which can be drilled into as well. But then again, I'm sure you guys are very familiar with prototyping, so let's move on to other applications we see potential in and have seen success in as well. Moving on to tools and tooling aids. So when talking to customers, especially those in manufacturing, there is always an underlying understanding that plastic will never be as good as metal, which is true in some aspects. Yes, comparing, say, the ultimate tensile strength of steel, plastics may not necessarily ever get there. But always ask a customer, do you really need that? So this is a good example where Formlabs printers were used for prototyping initially, so that's our starting point, but they move on to deal with the issue they had with an L bracket made of aluminum. So the L bracket was bending over time, being used on a gripper tool. A gripper tool is basically a machine on the conveyor belt which picks up part off one part of the conveyor belt and places on the second part of the conveyor belt. So you can actually see this specific customer, AMRC, Advanced Manufacturing Research Center, went through several design iterations, starting from the very left You can actually see the L bracket here slowly moving over 5 iterations to something more complex. So you can see here that Formlabs is being used for prototyping, but it doesn't end there. They eventually landed on an intricate spring-like design that was printed on our durable resin, which was great for this specific application, especially because of the springing back nature of the material. So unlike metal bracket that ironically plastically deformed after prolonged use, our 3D printed resin and durable actually served a better function. So this is a good example where prototyping led to toolings, and an example where plastics actually replaced metal. We have another example here where Formlabs printers were once again used for prototyping, but during a very time-sensitive project where they had to produce thousands of custom jigs for the production of gears, and their usual path, which will be outsourcing, couldn't address this essence of time. Our printers were used to print custom jigs, replacing outsourcing. So not only did Formlabs printers address the essence of time with a 90% reduced lead time, but also would lead to a cost saving of $170,000 over the course of production. So when talking to customers about replacing, say, a certain traditional method or whatever they're doing right now, always try to calculate an ROI. It may smoothen out some conversations, and if it is quite difficult to calculate ROI without having a full understanding of their current workflow. You can use case studies to sort of give them an idea of what to expect with other customers. So on top of cost savings, you can also talk about the scalability and the range of functional applications. Now, this is not always easy to do, but I do recommend and I do suggest that you always try to add value to our 3D printers. 3D printers in general are not necessarily for us, but 3D printers in general, what's so great about them is their versatility, their agility of the types of materials or the range of functions they can provide. We also try at Formlabs to continuously expand our collection of resin, not just to increase the addressable market for you guys, but also to add value for each and existing customer as well. So this is a good example from a huge furniture manufacturer called Ashley Furnitures. So they were once again using Formlabs printers for prototyping, a very common story, but they slowly realized that the materials could be used for many, many other applications on their factory floor. And now they're used for things like jigs, retainer rigs, drill bit guides, pin tack tool guides, air manifold mounts, and many more different varying applications. So these parts were actually mostly printed in tough and durable resin, and as of now, 300 3D printed parts are on the fabrication site, and an additional 400 3D printed parts are in the assembly area, totaling to 700 3D printed parts that are in service in the factory. So it really gives you a good idea of the scale, how 3D printers can be used for. And I understand trying to identify each of these varying applications is difficult to do when talking to a customer, but try to keep an open mind and ensure as part of customer education when you are talking to your customer that the customers themselves are informed of this potential, because they will best find out of the best applications of our 3D printers. So going back to Ashley Furnitures, thanks to Formlabs printers, they replaced nylon machined alignment pins that they had a minimum order quantity of 1,200, and they replaced it by printing them in-house with our durable resin, leading to a cost cut down, and also they were able to avoid any minimum order quantities. And also they were using it for many other applications. So tooling aids are commonly made with our tough and durable resin, as I mentioned just now, but never forget our other resins, which are quite functional. For example, our height temp resin here. So this is another example with nuclear AMRC. The customer is looking to develop brackets and sensor holders, especially in high heat environments, and they used to do this manually by having people walk into these areas, which was dangerous, hazardous, high heat, and it also took a lot of time to cool down for people to actually step in. So instead of depending on that, they instead got sensors everywhere, so they have a more streamlined workflow to identify if anything is going wrong. but when they tried to get sensors on, they needed brackets that could withstand high temperatures, which was, you guessed it, printed in high temp resin. So it gives you a pretty good idea. This is a very niche application, I would say, but nonetheless, keep your mind open to applications. I do see that we do talk a lot about our high temp resin to say, oh, it's great for injection molding or specific molds for silicone or thermoforming, etc. But the applications with 3D printers are unlimited, and I'd say the same for our resins as well. So don't cross out all the resins and focus on tough and durable when you're doing jigs and figs. Just keep your mind open. There are lots of resin that may actually fit into a customer-specific application. But moving away from jigs and fixtures, let's talk about mold making. So mold making, as you guys are already very familiar, is used across industries by product designers, entrepreneurs, and in manufacturing to create short production runs, prototyping of complex models, test production, and end-use plastics, and etc. So injection molding is specifically, just in general, is a versatile process that is used to produce high volume parts, but it may not necessarily, or it may not always be affordable. Actually, it's very unlikely to be affordable or quick and easy to produce, especially if you're CNCing these molds. Now with 3D printing or 3D printed injection molds, they tend to be faster and less expensive compared to CNC milling and other traditional forms of mold making. We do have a couple of case studies with injection molding. What you see on the screen now is a pretty good example with Braskem, where once again, there was a project that had to be dealt immediately, and they needed mask straps, and that too in the thousands. So they needed it in a crunch of time. I think there was a scale of, or a timeline of 2 days to 1 week, and outsourcing was clearly out of the question. And in-house FDM printers, which they did have, proved to be too slow. So that's where Formlabs 3D printers were used to print molds for injection molding on high temp resin. So you can actually see the high temp resin here, 3D printed injection mold here, and the injected part as well. So that way, they were able to produce thousands of mask straps in a week, each mold withstanding 1,500 shots, leading to a time saving and a cost saving of approximately 90% compared to traditional methods. And now, when I'm talking to customers who are interested in injection molding, the biggest or the most common question I get is, can our printed molds withstand their required condition? The short answer is, I don't know. Honestly, there are too many factors that are involved in this. I couldn't possibly conclusively deduce whether it will work in their specific requirement. But we can look at previous conditions to make a more educated judgment. So here are some case studies we have with injection molding with both rigid 10K and high temp resin. So there are success cases, but in no means do they define the limit of what we can injection mold. Now, a big shout out to Multiplus. Multiplus is our partner in China who has cooperated in testing and helped us document the entire process. So if you guys think there's an application we can develop together, we are always open to such ideas. Always reach out to me or your applications engineer in your region. For example, there could be applications such as composite molding with carbon fiber layup, which is a relatively uncovered application. But we do actually still see cases with this. We have seen 3D printed molds. You can actually see the high temp molds here, where they were 3D printed to make carbon fiber panels over the rear wheel of the car. You can actually see on the right-hand side on a racing car by panels. So there's literally a lot of different applications, but I'm not going to cover all of them. That was just to give you an idea of the scale of the 3D printed tools and tooling aids we have seen so far. But moving on to the next target application on production of final parts. So let's start off small scale with one-off parts. So this is with using castable wax outside of jewelry and dentistry. Castable wax has been used for casting out emblems of cars, as you can see in the picture, top right-hand side. And on the bottom right-hand side, you can actually see clear resin was electroplated with a thin layer of nickel to make hubcaps for concept models of the classic Volkswagen minibus from the 60s. So again, what a lot of people tend to miss out is that you can combine 3D printing with other processes, taking 3D printing or 3D printed parts to the next level. But moving on, let's have a look at more production in a larger scale that makes full use of the ability of 3D printers. That would be in mass customizations. I was hoping to talk about Gillette, but I do realize that is an overly used case study. We have an example here with Twikit. It's quite similar, I would say, to the case study we have with Gillette, where customers could pick out and design their parts, which they then ordered online, and parts were printed on a Formlabs printer. So this way, the customer Twikit doesn't have a mold. You don't have to invest in a mold. That makes it cheaper, and also you can maintain your flexibility to accommodate any custom parts for their customers. And of course, never forget, we do have our case with New Balance. I am aware you guys are very well aware of this, but I couldn't miss this one out, but I won't go into too much detail, so don't worry. But yes, shoe soles were printed on Formlabs rebound resin, specifically developed for New Balance. Don't cross out mass production level with 3D printers. We are getting there. Keep your eyes open for such applications, potentially maybe in audiology, dental orthodontics, etc. But anyway, that's pretty much what I wanted to cover for target applications, but the applications isn't the only thing you guys have to talk about when talking to customers, but you have to also compete with other printers as well. So let's have a look at some of the differences or comparisons between some of the printers we see ourselves competing with sometimes when talking to customers. So the first is going to be a comparison to Ultimaker S5 or just an FDM or FFF as a whole. I will say that there are a couple of benefits of Format 3 when you are comparing to FDM, but it does really come down to what the functionality is, what the customer is looking for out of the 3D printed part. Now, the reason I say this is because FDM, just being honest, they do beat us when it comes to cost of the part. But if the main focus of the customer isn't cost, rather it's the value, that's where you can offer a Format 3 with the range of functionality and the materials we provide, and of course the parts being isotropic, therefore being more functional, especially in load-bearing situations. But again, there are certain aspects where we won't win, such as the cost, so we are very much aware of it. We do try to add value to 3D printers, and that's why we talk about adding value. Comparing to Sprint Tray Pro DLP printers. So one thing our sales team faces, especially in the US, especially with DLP, is their incredible speed. So once again, I do see some of that, some parts that we may not necessarily win. I do agree with that. With that being said, speed really isn't everything. Some customers may prioritize it. I understand that, but it's worth noting that comparing, say, a printer that is, say, very expensive, getting multiple smaller printers, which is cheaper, may be a bit better way to sort of keep the print farms running. I bet you one fast printer, we might be able to win with 2 printers. So that's how I would phrase it, as long as the DLP printers are more expensive. And of course, what I do see a lot of the cheaper 3D or DLP printers is the serviceability. So with the Format 3, as you guys are familiar, and the Format 3L actually, there are a lot of serviceable parts, and of course the world-class supports you guys give as partners. So always talk about servicing as well. And now the famous debate, the Format 3 versus the Carbon M2 or Clip. Well, they only do Clip. Again, here there is downtime that we can always talk about. So if your customer prioritizes factors such as, what if you have one printer that's very expensive and multiple printers that are cheaper? There's always going to be that downtime you can avoid and reduce the risk with many printers that is cheaper. So ask questions. How will downtime affect your business? And do you plan on scaling up capabilities? So this does also apply to any expensive industrial printers out there in the market. I do want to highlight that I'm not saying that industrial machines or carbon printers are unreliable. I'm just saying that if something does go wrong, having one $75,000 printer and having several Formlabs printer does actually share the risk. And then we have our Stratasys object, or PolyJet as a whole, comparing Formlabs printers. The last few points I've previously covered also does apply here, but another question on top of that you can ask with PolyJet or Object 30 is, which material do you use and are you making functional parts? So the reason I say this is because with Object, it's really, really hard to switch between materials without wasting materials. And it's very, very time consuming. So typically when I ask that question and the user says, I only use one type of material and it's just a black material, etc., my follow-up question is, why is that? Are you not looking for more functionality? You're using a 3D printer. The whole point of a 3D printer is the range of things you can print. And a common response I get is that the switch between materials is a pain. That's why they stick to one material. So you can really address that when you are talking about Formlabs printers against Object 30. So I can't be going through all of it, so I'm going to really quickly move on. We do try to highlight a lot of the differences. I do understand that a lot of you get questions about, oh, how is it better or how is it different compared to other 3D printers? There are resources that we make available, like the one you can see right now on your screen. We do have it on our website, so keep an eye out for this. Quickly comparing the 3L. You can see here a quick comparison of size versus ease of use, comparing to 3D printers of the same size. Yes, Formlabs printers are easy to use. I don't know if you guys had the chance to use a 3L as of yet, but I'm going to just tell you right now, it's literally the same setup as the 3, so you can confidently comment that a large-scale printer is as easy to use as the 3. However, I do want to say that we are commonly overlooked by large industrial customers for their projects with high volume applications, and they usually go for carbon 3D systems, origin, EOS, because their positioning is more focused on manufacturing applications, and we are currently changing that. We are trying to make it more of a norm of scaling up from one printer to 5 to even a print farm, so that's where we're trying to head. In order to support that, we are producing more material. We are also trying to we are also ensuring that the materials we are producing meet the specific application. We have a custom success management in both Berlin, Somerville. You may think this doesn't apply to you, but a lot of the feedback you give us actually goes to them. And for example, Tough V5 was made from blue to Tough 2000 gray. That's one example where your feedback was reflected. And vertical specialization, we're making sure that we have actually, today's a very good example. We are ensuring that we have specialists in different verticals. We have Yasmin and she coming on later on. And then we also launched our factory solution to better address and support holistic production with Formlabs products. And then we have our growth. I'm going to skip that and then talk about what's coming next. We have Fuse, and we also have other products that are coming up to better support large-scale printers, large-scale applications, large-scale production. I'm going to say that it is coming, but I do want to clarify that there's been a lot of changes with Dashboard. I really, really suggest you check that out. We're implementing grouping to sort of make sure it's easier for multiple printers to work with multiple groups. So I do realize I went over time, so I'm going to quickly talk about materials and move on to Q&A. As you guys are familiar, we produce materials every single time, not just to increase the addressable market, but also to address that lifetime value of each customer, increase the functionality, increase value to our 3D printers. We even launched Rigid 10K, which is now used for injection molding. With that, I'm going to move on to Q&A.